Hello everyone, let us learn the basic idea about memory and memory hierarchy and its organization and architecture. Memory. Generally, in a digital computer, the data has been stored and it is worked as a programmed concept model which was introduced by von Neumann. So this memory is just a part of the computer where both the program and data are stored. So when during execution of any program, these two program and the data will be stored in the main memory. So when we consider the overview of the system, this central processing unit, which is going to perform the operation, will retrieve the data which has been stored in the main memory, and it will process the data, and the data again will be stored back to the main memory. So next, let us see about the memory hierarchy. Different kinds of memory is available at different levels. So when we start with, we have a register. This register is an inbuilt register inside the CPU. The next level is the cache memory. This cache memory just sits nearer to the CPU. So the processing speed of the cache memory is much higher than the main memory, which sits at the next level. And next to the main memory, we have a magnetic disk, and next to magnetic disk, we have a magnetic tape. So all the removable media will be kept at the last layer. So this is the hierarchy of the memory system. We'll have a register memory which sits inside the CPU, followed by the cache memory. Then we have a main memory. Main memory is your primary memory. And then we have a secondary or auxiliary memory, which is our magnetic disk or magnetic tapes. Just to give the insight, this register which sits inside the CPU is much faster. Next level is your cache memory, and next your third layer is our main memory, and your fourth level and the fifth layer will be the auxiliary memory, that is the magnetic tapes and the magnetic disk. With respect to the speed, CPU registers are much faster than the cache memory. Then when compared with the main memory, cache memory are faster. When compared with the magnetic disk, main memory are faster. When compared with magnetic tape, magnetic disk are faster. So the hierarchy goes from register to magnetic tape. With respect to the storage capacity, registers are very small, so it could store a minimum number of data inside to it. So if you want to increase the size of the data, then we have to go with the higher levels of the memory. So memory hierarchy is to obtain the highest possible access speed while minimizing the total cost of the memory system. When we concern with speed of the memory, it is much critical. So when it is just sits next to the CPU, the speed is obviously high when compared to the next levels. This slide gives a complete insight of the relationship happens between the speed, the size and the cost of the memory hierarchy. CPU register, which sits inside the CPU, it's very fast and its accessing speed is just 1 nanosecond. And the size is very limited with max of 512 bytes. But its cost is very expensive because it comes as a part of the CPU. Next level is your cache level, and this cache level is quite faster than the main memory, but it is slower than the CPU register. So it's the speed has been measured in terms of 10 nanosecond, and the size has been identified with maximum of 12 MB, and it is also expensive when compared with your main memory. Next is our main memory, it's a RAM, and the fast has been measured with 100 nanoseconds, and the size is measured with 8 GB, and it is inexpensive. The hard disk, that is a secondary storage, it is slow with 10 millisecond, but it could store large data with the size of any variable of 2 TB here, and it is very inexpensive when compared with your CPU registers and cache. And the last layer is your magnetic tapes and drives. So the accessing speed is very less when compared with all other levels. So it is in terms of seconds, and we could store potentially large data of petabytes. And it is least expensive when compared with the other layers of the memory. Thank you for watching this video. In our next video, we will learn about the memory organization. Thank you.